So we go ahead and we plot histograms now for multiple variables. And we do this just by passing games. And so you see when we previously did a histogram, what we did was we passed games.size, so a single column. So whatever histogram gets, that's what it plots a histogram of. So if it gets multiple columns, then it'll plot histograms for each one of them. So if we pass all of games to histogram, it plots histograms for all of the numerical columns. It obviously doesn't plot things for non-numerical columns like the title. And so here we see the results. Now, the histogram for ID is nonsensical. It's just the identification number. Average user rating makes sense. So you see that most of them are 4.5. You also see that it's quantized, right? It's 2.5, 3, 3.5. There's no such thing as a 3.1 or 3.2 or 3.3 rating. Now, when we look at user rating, price, and size, we get a histogram, but the histogram is not very informative. And that's because there are these outliers on the right side of the chart that are essentially making it hard to read and reducing the amount of information. So here, what we do is we exclude the largest values. So we're going to exclude the largest size, the largest user rating counts, the largest price. And then we're going to replot the histogram. So here, we're eliminating the top 5%, okay? And here's how we do that. So games less than games price quantile filter cutoff will return true or false values based on whether or not the price is in the bottom 95%. So what games price quantile filter cutoff does is it returns the price that is at the 95% mark, at the filter cutoff mark. And so anything that's below that is true, otherwise it's false. And then we do that for filter user rating and filter size. And why did we choose these three, price, user rating count, and size? Because these are the things that are causing problems, user rating count, price, and size. And so we're eliminating the top 5% in this case. You can change this depending on what you want the cutoff to be. And then at the end here, we exclude all of them, right? So we do an and. So it has to be in the bottom 95%. So we're excluding 5% for all of them. So in some sense, we're excluding all of the games that have extremely high values for any one of these three columns. And then we take these new data frame, essentially, just the ones with everything eliminated, and then we plot the histogram. And so now when we look at user rating, price, and size, we see that we have more information. So size is really obvious here. So here we can actually see the histogram, whereas here we did not, okay? Now, for the other two, user rating count and price, we see a little bit of information. So number one thing we see with price is that it's also quantized. So it seems like there are a whole bunch of games that are $0, and then there are games that are 99 cents, and then $1.99, and then $2.99, and very little in between. So that's more information than we got before from price, where we just saw this one little bar. But then since it apparently goes up to 175 or 200, everything else was hidden because we didn't see any of the bars. But we could keep doing that. For example, with user rating count, maybe we get a little bit more information, but maybe we want to exclude even more by increasing this number or doing some other sort of analysis that's similar to this one. So here we're going to do a box plot of size. And if you'll remember, what the top whisker does and the bottom whisker does is it looks at outliers. So one thing, maybe the obvious thing that comes out here is that there are a lot of outliers that are really, really big. Okay, so one thing that might be useful to do is to actually look at these games. And so we can find out what the games are and then go find them and look at them and see why they're so big. So let's now go on to a different parameter, and this is the age rating. So here we use value counts, and we see that in the age rating of 4+, we have 11,806 games. We can create a bar chart by just passing value counts to plot kind equals bar. So we have a nice visualization. We can also normalize this. So these are just the raw counts, but we might want to have percentages. And so if we say pass normalize equals true, we get a percentage. We see that 70% of the games are 4+. Okay? We can also plot a pie chart. That's a different kind. This is maybe one of the few times when a pie chart might be useful when you're doing this sort of percentage. And then we can also just show the raw values. So 12% of the games are for 12 plus. So this has been looking at single parameters, and now we're going to look at relationships amongst parameters.